A ship sails 8 kilometers on a bearing of 70 degrees and then changes direction to sail 10 kilometers on a bearing of 30 degrees. So first we need to draw a diagram to represent this, and then what is the ship's distance from its starting point, and then on what bearing must it now sail to get back to its starting position. So what I can do is well, let me say the ship is here. It's starting from here, and then there is a bearing, so I have to draw a north line. So this is the north, and the ship is at a bearing of 70 degrees. So then this is 70 degrees, and then it goes 8 kilometers. So this is 8 kilometer, it waits here, and then it changes direction. So there's another north, and then it travels for 10 kilometer, and this is north as well. Then once it reaches this point, it wants to turn back. So when it is turning back, we've got to do a bearing again. So that's what it is so far. So this is 30 degrees, and that's 10 kilometer. Well, of course the drawing is not perfect because my 10 kilometer looks smaller than 8 kilometer, but roughly that's what it would look like, making the line longer. So then the next part, the first part is done. For the next part, what is the ship's distance from its starting point? To work out the ship's distance, I'd have to join the endpoints. So it's like I can call this A and this B and C. So I'd have to work out what AC is. So I drew a better diagram, and this is my better diagram. Okay, so here I'm going to have so I'm going to name these points. First I'm going to join them. So that's if I say that is A and this is B and C, and this entire thing is 70 degrees, and this bit is 30 degrees, and I need to find out what AC is. So what I will do is I have to find some of the other angles. I have to find out what this angle is. So this angle, or angle, if I name this point as let me see, if I name this as D, then I've got to find what angle DBC is. So you see these north lines are all parallel to one another. So if I call them EF and GH and IJ, so they're all parallel. So therefore angle ECD must equal, yes, so must equal, angle ECD must equal angle that would be angle G, or I should say CBH, angle CBH. So they are equal, they're alternate angles, so we can say alternate angles, right? So then this is also 70 degrees. Now therefore that would be angle DBC would equal 180 minus 70, and that is 110 degrees. So therefore angle CBA equals 110 plus 30, that is 140 degrees. So I can now use the cosine formula to work out what AC is, because I know that CB is first 8 kilometers, and then it is 10 kilometers. BA is 10 kilometers, so I can work out what AC is. So I will, the side opposite A, I will say that this is, if I call this as A, and this as AB as C, and AC as B, then I have to work out what B is. So I can write B square equals A square plus C square minus twice of AC and cos B. So B square I don't know, so that equals A square. A square is 8 square plus 10 square minus 2 times 8 times 10 times cos of 140 degrees. So that will be, so that is 64 plus 100, that's 164, minus 2 times 8, 16, 160, multiplied by cos of 140 degrees, and that equals 286.567. So then I got to, that is, let me write down. So we get B square is 286.567. So therefore B equals the square root of 286.567. So if I do the square root of this, I would get 16.9. So that is correct to 3 significant figures. Okay, so that is the answer to part B. So the answer is 16.9, 3 significant figures. So then I have B. Now I need to find out on what bearing must it sail to get back to its starting position. So for this bit, I need to find out this entire angle. So I need to find out angle IAC, the reflex angle. Okay, for the bearing, so the anti-clockwise. So that would be, so this is 180 degrees. IAJ is 180 degrees. Then angle BAJ, you see, would be 30 degrees. The reason being, angle GBA equals angle, because they're alternate angles, say they're alternate angles, so this angle would equal this angle. Okay, so would equal angle, so did I get it right? GBA, yes, equals angle BAJ, right? BAJ. Yeah, and that is also 30 degrees. So angle did I say, yeah, angle IA, not IAC. Sorry, I have to find out angle IAD. Let's see, it's a mistake. Need to find angle IAD. IAD. So that's the angle I need to find. So we already know what IAB is. Angle IAB equals 180 plus 30 is 210 degrees. Right? But what I don't know is this angle. I don't know why I write in red. Is this little is this angle. So is this angle I don't know. So what I don't know is angle CAB. So angle CAB is what I don't know, and that is the angle we need to find out to answer part C. On what bearing must it go? So and then to CAB I have to add 210 degrees. So I will do that. We can use the same formula, but instead of B I'm going to have A. So when I have A, I am going to use A square. So I'm going to use A square equals B square plus C square minus 2BC cos of A. So then B I know. I will also write down somewhere what B square is. So B square we found out is 286.567. So we can erase the rest of it. Don't need this. So we get so A square, we know what A is. Yeah, so A square, this A is 8. And we know what B is, B square is. We know what C is. C is 10. So then we got to use A square minus, or we have to bring that this side. So 2BC cos A equals, so 2BC cos A equals B square plus C square minus A square. So therefore A will be cos inverse of B square plus C square minus A square divided by twice of BC. So I have to work this out first and then I will apply the cos inverse. So that would equal cos inverse of B squared is 286.57 plus C square is 100 minus 64 divided by twice of BC. So 2 times 286.57 BC. Sorry, can't do that anymore. 16.9 2 times 16.9 and times C is 10. So that's what it is. So if I did that, I would get brackets so that gives me cos inverse of 0.9543. So if I say that, and now I'm going to apply the cos inverse. So I get 17.38. So I get 17.38. So therefore A equals 17.4. So if it is 17.4 degrees, so what I get is the bearing angle, which is CAB. So that would be $227.4. So I get 0.4. So angle CAB would be so if I have to use three significant figures, I would get 227 degrees. So on bearing, it must now say to get I get 227 degrees.